Hello everyone. So today we are going to do some numericals on magnifying glass or a simple microscope, compound microscope and astronomical telescope. So we have already discussed what are the magnifying power for simple microscope, or we can say another name of it is magnifying glass, compound microscope, and astronomical telescope. So today we are going to discuss some numericals on astronomical telescope, compound microscopes or simple microscope or magnifying glass. So today's topic is numericals. So we are going to take the first numerical. If subconscious says a person has his near point at 15 centimeter. This is our least distinct vision, and a range of distinct vision of 85 centimeter. We have to calculate what is his range of distinct vision when he wears close fitting spectacles which having a power of minus 0.8 diopter. So here we have given a person has his near point at 15 centimeter and a range of distinct vision of 85 centimeter. So we have to calculate what is the range of distinct vision when he wears the close fit spectacles having a power of minus 0.8 diopter. So solution for this will be what we have given. First will write given that power is equals to what? Minus 0.8 diopter we know focal length is reciprocal of power. True enough. So if you have to calculate the focal length, so it becomes 1 upon 1.08. that means the in meter, which is, if you calculate, approx 125 centimeter. Sorry. So the given power is given minus 0.8 diopter, and if you have to calculate the focal length, if we recall the formula for in relation between focal length and power, so focal length is nothing but the reciprocal of power. So on substituting the value of power here, so we calculate focal length, which becomes what? Minus 125 centimeter. Okay, in first case, case, let the near point, let the near point using specs or spectacles, specs be at a distance of say u1 centimeter in centimeter, okay, from the eye. So in first case, let the near point using spectacles be at a distance u1 from the eye. This is our first assumption. So the final image we have given where the first person has a near point at 15 centimeters. So we have given V is minus 15 centimeter. All good. If we calculate, we know the lens maker. We know the lens formula. One upon V minus 1 upon U, which is now U1, is equals to 1 upon F. Good enough. We had the value of V, so if we need to calculate 1 upon U1, so here become this quantity goes 1 upon V minus 1 upon F. Is it okay? So substituting the value of V is your 15 of negative sign. Again we have what, 1 upon 125. We had calculated what, focal length is 125 centimeter. On solving this, approximately we will get u1 will becomes almost 17 centimeter. On taking LCM of this, we can get to know what u1 will become minus 17 centimeter approx. Okay, I'm taking only approx value. Now we have given the second case. Let me write in the second case. In the second case, let the far point using spectacles be at a distance of say u2 in centimeter from the eye. So V becomes here how much, minus 15 plus 85 centimeter. So total value becomes here, again this will be negative sign. Okay, let me take the negative sign back. Here. So this becomes 100 centimeter of negative sign. Okay, so V becomes here minus 100 centimeter. Again we know the lens formula, 1 upon V minus 1 upon here u2, which becomes 1 upon F. So if I need to calculate 1 upon u2, 1 upon u2, so this becomes 1 upon V minus 1 upon F. So 1 upon V is 1 upon 100 centimeter minus, we had already calculated, it is, this quantity becomes minus plus, because we know F is your 125 centimeter. Good. So on calculating this, taking LCM of this, we calculate u2 as what, 500 minus of 500 centimeter. See, we had calculated u1 as minus 17 centimeter and u2 as minus 500 centimeter. Hence, if you have to calculate the range, here we had asked what is the range of the vision. Hence, the range of vision, will equals to 500 minus 70, is almost 483 centimeter. So this is what we have to calculate. This is the answer. So this question is from your magnifying lens. If we can calculate next, we'll take the next question from a compound microscope of a telescope. So suppose we have given another question from telescope. Okay, this question is from telescope. So second question is your the focal length sorry, the focal length of a objective lens of refracting of a refracting telescope is 100 centimeter, and that of eyepiece is 5 centimeter. If the final image, the final image is formed at d distance, which is 25 centimeter. That means least district vision find magnifying power and length of telescope. Okay, so we have given what we have to calculate the magnifying power for telescope and length of a telescope. If we have to solve it, if we memorize the ray diagram for a telescope, astronomical telescope, we have a larger, we have a objective lens, okay, let me write here. If we have an objective lens of larger focal length and large aperture. Okay, if this is my principal axis, and eyepiece says the focal length of this is FO, and focal length of eyepiece is this objective length. This is eyepiece. or ocular or ocular. It will have small focal length and small aperture comparatively to objective lens. Okay. In comparison of this objective lens, this eyepiece will have a small focal length and small aperture. Okay, so we have to calculate what eyepiece. So eyepiece or ocular will have a small focal length comparatively to the objective lens. So we have given here, if we raise this one, suppose we have given what focal length. If we calculate here, focal length of objective lens is 100 centimeter. And focal length of an eyepiece is 5 centimeter. Okay, and at a d distance, image it at a d distance, final image, which means 25 centimeter. Okay, so we have to calculate what magnifying power and length of a telescope, which is denoted by L. All right, so let me erase this. Let's make a ray diagram for an astronomical telescope. Then we will let know what is going on here. Okay, so object is at infinity. For an astronomical telescope, object is at infinity. All right, so means parallel rays will come at objective lens, here, and it will converge at focal plane. Here will be the focal plane of objective lens. Says the length of object is AB here. Okay, height of the object is AB, which is an infinite. So the first image will be at A dash B dash. If we will redraw that eyepiece edge, so this is our eyepiece. Intersect here. A line passing through center will appear to converge somewhere here. Okay, so this will be this distance will be the B dash, B double dash, A double dash. so the image of objective lens will behave like an object for an eyepiece. So the final image will be at B dash, A double dash. So this length is FO, and as we can say, the A dash B dash is the object, or we can say the final, and the image by objective lens will behave like an object for an eyepiece. So this distance is UE. So we know length of a telescope, a telescope is, which is denoted by L. This is the sum of FO modulus of this one plus object. So total distance, this one, this is your L. All right, and in question we have the image is at final where from the eye at a d distance, this. So we need to calculate first length of a telescope, and we need to calculate the magnifying power. So for the magnifying power, generalized form of magnifying power of an astronomical telescope is FO upon UE, and for final image at D becomes your formula magnifying. We had this already discussed in our last lectures. So this becomes FO upon FE. This becomes 1 plus FE upon D. From question we have what we have? We have FO is your 100 centimeter and FE is your 5 centimeter. All right, substitute value here. M is your FO is your 100 and F is your 5. All right, where 1 plus F is your 5, D is your 25 centimeter. D is your 25 centimeter. Now if we calculate, this becomes 20 and this becomes 1 upon 5. So here 20 multiplied by 1 plus 1 upon 5, this becomes 24. So the magnifying power will be 24. Okay, now we have to calculate. Now what we have to calculate? We have to calculate what? The length of a telescope. So for length of a telescope, this is normal. So we have to calculate the length of a telescope. So as we know that for final image at D by eyepiece, here UE is minus UE. Sorry, your U is final image. This is your U. So this V is your minus D, which is 25, and focal is your 5. Okay, so 1 upon F is equals to 1 upon V minus 1 upon U. So 1 upon 5, this becomes 1 upon minus 2, 25. Sorry, minus of UE. So 1 upon UE becomes 6 upon 25 on solving this, or UE is 25 upon 6, which becomes 4.166 centimeter. All right, now we know that the length is focal length plus UE. Substitute here, focal length is 100 plus 4.166, so this becomes 104.166 centimeters. So is the length of a telescope. L is length of telescope. Okay, so this is our length. This is the final length. All right, so this is our what we have discussed: one numerical of telescope and one numerical of magnifying power, and or we can say the simple microscope. So next class we will discuss the one numerical of compound microscope. Thank you.